Hi y'all, Professor Marianne Barber here. In this lesson titled Lines, we will briefly review slopes and how to find equations of lines. Upon successful completion of this lesson, you will be able to 1. Find the slope of a line given 2 points, or from an equation, and also from the graph of a line. 2. Be able to find the equation of any line. 3. Be able to express the equation of a line in point-slope form, slope-intercept form, and the general form. And 4. Be able to find the slope and equation of the line that's parallel and perpendicular to any other line. Roman numeral 1. The slope of a line. The slope gives the inclination of a line. That is, it provides a measure of steepness. The graph of a line is presented. The line is primarily in the first quadrant and 2 points are marked on it. The points are x1, y1 towards the bottom of the graph and x2, y2 towards the upper end of the graph. A perpendicular segment is dropped from the point x2, y2 and a horizontal line segment is drawn to the right from the x1, y1 point so that they meet at a right angle. The point of intersection is the ordered pair x2, y1. The slope is a ratio of two numbers that are used to describe the rate of change. To derive the slope formula, we denote the vertical distance from the x2, y2 point of the line to the point x2, y1 as the change in rise, y2 minus y1. Similarly, we denote the horizontal distance from x1, y1 to the point x2, y2 as the change in run of x2 minus x1. So the formal definition is the slope m of a non-vertical line that passes through the points A, denoted with x sub 1, y sub 1, and B, denoted with x sub 2, y sub 2 is m equals the change in rise over the change in run, that is equal to y2 minus y1 quantity divided by x2 minus x1 quantity. The slope of a vertical line is undefined and the slope of a horizontal line is 0. Roman numeral 2. Forms of an equation of a line. We have several common forms of an equation of a line. Let's get these out of the way. Definition. An equation of the line that passes through the point x sub 1, y sub 2 and has slope m is given by y minus y sub 1 is equal to m quantity x minus x sub 1. This is known as the point slope form of a line. Definition. An equation of the line that has slope m and y-intercept b is given by y equals mx plus b. This is known as the slope-intercept form of a line. Definition. The graph of every linear equation can be expressed in the form ax plus by plus c equals 0. Conversely, every line is the graph of a linear equation. Find the equation of the line with the following properties. A. Slope m equals 3 and goes through the point -2, 5. Given point and slope, it makes sense for us to use the point-slope form of the equation of a line, which is y minus y subscript 1 equals m times the quantity x minus x subscript 1. Now let's substitute in the values. We'll do y minus y sub 1 is the y value of the ordered pair, 5, equals, the slope is 3. Then we have x minus x sub 1, which is the x value of the ordered pair, so write -2. Let's simplify. Y minus 5 equals 3 times the quantity x, and minus negative becomes a positive, so plus 2. Continuing, let's distribute the 3. Y minus 5 equals 3 times x is just 3x. 3 times 2 give us plus 6. Now add 5 to both sides of the equation, and you get y equals 3x plus 6 plus 5 is 11. We typically express our answers in the slope-intercept form. That's the form y equals mx plus b, because it also is the form for the linear function. Continuing to part B, find the equation of the line that goes through the points 2, 7 and negative 3, 6. To get the equation of a line, you have to have two pieces of information. They are a point, in which we're given 2 of them, and the slope. We don't have a slope, so to begin this problem, let's find the slope. The slope is given by the formula m equals y subscript 2 minus y subscript 1 divided by x subscript 2 minus x subscript 1. We'll pick our points, and so we'll start in the numerator with 6 minus 7 for the y components and negative 3 minus 2 for the x. Continuing with arithmetic, 6 minus 7 is negative 1, and negative 3 minus 2 is negative 5. The negatives cancel, and we end up with slope m is equal to positive 1/5. Now that we have the slope, we can use either point in the point-slope form of the equation of a line, y minus y1 equals m times x minus x1. I'll choose the ordered pair with no negatives. That limits the amount of errors I can make. And so we'll have y minus, and for y1, 7 equals the slope value we just obtained, which is 1/5, times x minus the corresponding x coordinate is 2. Let's continue. So we have y minus 7 is equal to, distributing the 1/5, you get 1/5 x minus 2/5. To isolate the y, you need to add 7 to both sides. And so when you finish, you have y equals 1/5 x, and then negative 2/5 plus 7, remember to get a common denominator, will give you 33/5. Part C, find the equation of the line that goes through the points 7, 3 and negative 8, 3. As with the previous part, you have to have a point and a slope to get the equation of a line. Since we're not given the slope, let's find it. The formula for the slope, which you have committed to memory now, is m equals y2 minus y1 divided by x2 minus x1. This would be equal to the difference of the y values, 3 minus 3, and the difference of the x values in the denominator, negative 8 minus 7. The numerator simplifies to 3 minus 3 is just 0, and the denominator, negative 8 minus 7, is negative 15. 0 in the numerator tells us that the slope is 0. Furthermore, a slope of 0 means you have a horizontal line. So it means it's a horizontal line. And for the equation of a horizontal line, you can just do y equals b. Remember, m is 0 and b is the y-intercept. And we know what the y-intercept is because it's the same value for both of the two ordered pairs given, which is 3. So the equation of the line is y equals 3. By the way, if you recognized at the onset that these 2 points gave points of a horizontal line, it was sufficient, or it would be sufficient for you to just write y equals 3. Roman numeral 3, parallel and perpendicular lines theorem. 1. 2 non-vertical lines are parallel if and only if they have the same slope. 2. 2 lines with slopes m sub 1 and m sub 2 are perpendicular if and only if the product of m sub 1 times m sub 2 equals -1, or solving for m sub 1 equals the negative of 1 divided by m sub 2. Let's note that perpendicular lines meet at a right angle. Consider the line 3x minus 5y plus 4 equals 0. Find the equation of the line that is A, parallel to that line and goes through the point 2, 7. Now, in order to get the equation of a line, you need 2 pieces of information. You need a point and a slope. We are given the point 2, 7, so now we need the slope. Parallel means the same slope. So from the given equation of the line, 3x minus 5y plus 4 equals 0, we will rewrite this into the slope-intercept form, which is y equals mx plus b. Then the m that's multiplied to the x will give us the slope. So we'll get y by itself. That's negative 5y will be equal to, subtracting 3x from both sides, is minus 3x, then subtracting 4 would then give you minus 4. Now, in order to get the y by itself, let's divide by negative 5, term by term. So negative 5y divided by negative 5, negative 3x divided by negative 5, and negative 4 divided by negative 5. We'll clean this up, and then negative 5 over 5 is just 1, so y equals negative 3 divided by negative 5 is positive 3/5 x. Negative 4 divided by negative 5 is positive 4/5. Now we can see the slope. The slope of the given equation, m, equals 3/5. With the 0.27 given and the slope of 3/5, we can use the point slope form of an equation, y minus y1 equals m times the quantity x minus x1, and solve for the equation. That would be y minus, for the y1, 7 equals m, the slope we just obtained, 3/5, x minus, and the x1 is 2. Let's clean this up a little bit. Get y minus 7 is equal to, distributing the 3/5, 3/5 x minus 3/5 times 2 is 6/5. Add 7 to both sides of the equation, and we get a linear equation, y equals 3/5 x. Negative 6/5 plus 7 is positive 29/5. The equation y equals 3/5 x plus 29/5 is the equation of the line that goes through the point 2, 7 and is parallel to the line 3x minus 5y plus 4 equals 0. Part B, find the equation of the line that is perpendicular to the line 3x minus 5y plus 4 equals 0 through the point 2, 7. We got in the previous part that the slope of the given line, m, is the value 3/5. We also know that by the definition of perpendicular slope, okay, we know that the slope of a line that is perpendicular to a given 1 is negative 1 over m. So in solving for the slope that is perpendicular to 3/5, we want the negative of that, and the reciprocal 1 over 3/5, which takes us to m perpendicular is equal to negative 5/3. Now we have a slope and a point, so we can use the point-slope form of the equation. Y minus y1 is equal to m times x minus x1. Let's substitute in the values. Y minus y1 is 7 is equal to the slope, which we know is negative 5/3, multiplied to the quantity x minus the x-coordinate, which is 2. Let's simplify. Y minus 7 is equal to distributing negative 5/3 to the terms in the parentheses, negative 5/3 x. Negative times negative gives us a positive, and 5/3 times 2 is 10/3. Now we want to isolate or solve for y, and you do that by adding 7 to both sides of the equation. Then the equation for the line that is perpendicular to the given 3x minus 5y plus 4 equals 0 through the point 2, 7 is y equals negative 5/3 x plus 31/3. Equations can be described in several different ways. We're most common with equations being described by an equation. For example, 3x minus 5y plus 4 equals 0 can also be described as y equals 3/5 x plus 4/5, and that's a line with an increasing slope. Now, the equation y equals 3/5 x plus 29/5, that also gives a line with an increasing slope, and it is parallel to the original equation. We also have the graph with a downward slope that intersects both the original and the parallel equation at right angles. This is the equation of the perpendicular line, y equals negative 5/3 x plus 10/3. A dam is built on a river to create a reservoir. The water level W in the reservoir is given by the equation W of t equals 4.5t plus 28, where t is the number of years since the dam was constructed and W is measured in feet. Part A, sketch the graph of this equation. To sketch the graph of this equation, which is a line, we need only 2 points. From the equation, we know that the y-intercept is 28. We can mark that point on the grid. The slope is 4.5, which means up 4.5 units for every 1 unit to the right. We can sort of approximate that by starting at the y-intercept point, going up a little bit, and over. Connect the 2 points and we've got the line. Or you could, and I would, select a different x input value and evaluate it in the equation. I decided to choose x equals negative 4. Then in the equation, W of negative 4 is equal to 4.5 times negative 4 plus 28. 4.5 times negative 4 is negative 18 plus 28, which gives us a nice whole number of 10. The ordered pair negative 4, 10, we'll locate it on the grid, is much easier to locate. We can connect those 2 points and we'd still have a line. So here is our line with the points marked. Now, let's add a reasonableness component here. For a line, the domain is all real numbers. In this equation, however, the t, the input, is for the number of years, and time cannot be negative. So even though the graph of the line spans the entire number line, the graph of this equation should have a starting point at t equals 0. Time outside of the Doctor Who world and a couple of Star Trek episodes cannot be negative. Part B. What do the slope and y-intercept of the graph represent? The slope, t, is the number of years since the dam was built. It represents the time. The w-intercept is the water level of the reservoir the year the dam was built.